MacMaths, MacMaths. Let's do some maths today. Okay, so this is chapter 1. The chapter's actually called Algebraic Expressions. It's from the AS book, the core, but we're looking at, the lessons I'm going to do are on indices and surds, because all of the other stuff is a bit too much overlap for GCSE, and you lot seem really clever anyway. Okay, so I'm just going to go through the indices, give you a bit of practice, look at some common misconceptions and mistakes that you may be tempted to make, so hopefully we'll avoid those in the future. I'll do a little bit of support with exercise 1D, that's on page 11, so I hope you're sort of going to go through that, and I've done some extension problems for you that extend what is covered in the book, okay, and that will just make you a better mathematician. All right, I know the first lesson was a bit short because we obviously set it up and everything, and so I just wanted to go over some things with you and just make sure that you're sort of settling in and you're getting into your maths. Okay, all right, so here we go. We'll look at indices first. Okay, I've done some questions for you to start off with. These are the basics. So what I would do now if I was you is put it on pause, have a go at those three. You're simplifying them, so just have a go at those and then I'll go through them in a second. Okay. Right, you're coming back from pause, and I'm going to do these now. Okay, so this first one, so it's all of this cubed, isn't it? So it's going to be, you could, if you wanted to, write it out. I'll do it on this side here. In fact, can you even sort of see that there? Yeah, you can. Okay, so you could write it as 6x squared y times 6x squared y times 6x squared y. If you wrote it out in full, that's what it is. So it's 6 times 6 times 6, which is 36, which is 216. I think, I don't know. Hang on, let me just check on my calculator. 6 cubed is equal to 216. It is. X squared times x squared times x squared is x to the power of 6. Remember, in this index laws, we're adding the powers, and y times y times y is y cubed. Of course, you can just cube the 6, cube that. Remember, you times the powers, don't you? It comes from that x to the a or to the b is x to the ab, okay, and y cubed. This one, remember, ignore the minus for a moment. I always tell my year 11s to ignore the minus, then everything to the power of a half. So 16 to the power of a half is 4. X to the power of 4 to the power of a half, well, you can just like times that out, and 4 times a half is 2. Remember, a half is the square root. The square root of 4 is 2, so it's x squared, and that, of course, is y. Okay, now we've actioned that. Okay, we've square rooted all of that, and the minus means 1 over. So there's your answer. 1 over 4x squared y is what you should have. Okay, of course you can, if you want, move all of that to the top and go 4x squared y and put it in brackets and put to the minus 1, because that's what that minus means. It means 1 over. So you can have it as minus 1, but we like it as a fraction. This one, ignore the minus again. To the power of a half, it's the square root, isn't it? The square root of all of this, nice numbers, is going to be 7 over 4. Square root of 49 square. So 7 over 4 times 7 over 4 is 49 over 16, okay? So it's that, we've actioned this, it's all that to the minus 1. Now we're going to do the minus. And the minus means 1 over. Now 1 over 7 over 4, okay? That's what it is. It's 1 over 7 over 4. But 1 over 7 over 4, well, think of that another way. That is 1 divided by 7 over 4, isn't it? That line means divide. So it's 1 divided by 7 over 4. And if you've had Mr. Orme, he's taught you KFC, hasn't he? Keep, flip, change. When you're dividing fractions, you keep the first one, which is the number 1. You flip the second one, 4/7, and you times. And 1 times 4/7 is 4/7. Okay? Now you don't need to do all that, but I wanted to show you that when anything is to the minus 1, if it's a fraction, you just flip it over. It's always 1 divided by, and you just flip it over. So it becomes 4/7. So you can do that next time, can't you? Okay, and that next time is going to be with question 4. Okay, so this is always do the root first because it makes it easier. So we're going to do this root. So I'm not going to put equals now. I'm going to use an arrow because an equals would not be appropriate. This next line is not equal to that. But I'm going to go through these in stages. My first stage is to action this cubed root, and that is 3 over 4. Okay, so I've actioned that. My next stage is to action this squared. The top is the power. So square both of those, and now I've got 9 over 16. Okay, that squared and that squared. And the last thing is I'm going to action the minus, okay, which is 1 over. Now we've done all of that this time, 1 over, because it's a fraction, we can just flip it upside down. So it becomes 16 over 9. Okay, so I hope that made sense with those. And I hope you had a good go at those. Right, let's have a look at, I thought I'd do a couple of misconceptions with you. Okay, let's rub those out. Get rid of all of that now. Get rid of that. Right, my misconceptions then. I call them misconceptions, but they're really mistakes that we see. And I wrote them down just to remind me what. So I thought about the mistakes that we often see. Oh yeah, so the first one, because you know that when you see that to the minus 1, we know that that means, the minus means 1 over. So this is 1 over x to the power of 1, which is just x, of course. And x to the minus 2, of course, will mean 1 over x squared. That's fine. Okay, so a very common mistake early on with students is this one. Okay, so if we put a number in front of that and go 5x to the minus 2, okay, now let's just make it simple. Let's just go 5x to the minus 1. Students will often go, well, that's 1 over, so it's 1 over 5x. Okay, and that is it's not true. That's a common misconception. Okay, so don't make that mistake. It's only this x that is to the power of minus 1. So 5x to the minus 1 can be written like that, or the x to the minus 1 is 1 over x. So it's 5 times 1 over x. In other words, it's 5 over x. So it's only the x that moves down. Okay, so just be careful with that. Okay, so don't move the number down as well. All right. Remember when you see numbers on the bottom. Okay, when you see something on the bottom, let's put a letter on the bottom. So like x to the power of minus 4 on the bottom of this. How else could we write that? Well, this on the bottom is 1 over x to the 4. You know, it's 1 over x to the 4. That's what that is on the bottom. And again, it's divide by a fraction, so it's invert and multiply. So when you see the minus on the top, you can just ignore the minus and write what it is, you know, on the bottom. But when the minus is on the bottom, of course, you can just flip it back up to the top. So that would, and lose the minus. So that would just be 7x to the power of 4. So sometimes you see a minus on the bottom. It just allows you to move whatever it is to the power up. If it was, again, that, okay, 7 over 2x to the power of minus 4, okay, you cannot, it's not the 2 that's to the power of minus 4. There isn't a brackets around all of that. So again, that's a misconception, okay? You have to then go 7 over 2, and it's only this that would move, that moves up. So it's 7x to the 4 all over 2, or 7 over 2 times x to the 4, okay? All right, so don't move those numbers up and down like we did here, you know, as a mistake, you know, with the letter. Okay, so that's a common misconception. And the other thing, the other mistake that you might be tempted to make is when you've got something like, I don't know, 2 to the power of x, something like that. Okay, remember this 2 is wrapped up with this power, so you cannot go 10 divided by 2, and that is not the same as, you know, 5 over 1 to the power of x or something like that. It is not. Okay, so you cannot cancel out this fraction. You know, you can't really do anything with that. You can move it up if you want, but then you'd have to write it as 10 to the 2 minus x, if you know. So it'd be 10 times all of this, 2 to the power of minus x. Okay. Yeah. And again, if it's confused you because the letters there, think of it as this here is if we move it up, it becomes from being a positive to the minus 1. So to move it up, so it's like 10 times 2 to the x to the minus 1, and then you can multiply those powers out, can't you, to be 2 to the minus x. Okay, so just be careful with those when you're moving stuff around with indices. The main one, of course, again, I'll just say it again, if you see something like 2x to the minus 1, do not write that as 1 over 2x. Okay, it isn't. Okay, it's 2 over x. Okay, it's not that, and it is this. That x moves down. All right. Now then, what I'll do is, I did have an order there. I'm going to do support with exercise 1D. Exercise 1D, you can go through those yourself, okay? But I noticed that the last two, the book is saying are exam questions, so I'll do question 4 and 5. Very quick to write down. Have a go at them first. It says find the value of 81 to a quarter, so really simple. And B, simplify x times 2x to the, what's that, minus a third. Ooh, all to the 4, that's a 3 there. Okay, so that's question 4. And question 5, it says, given that y equals an eighth x cubed, write in the form of kx to the n, where k and n are constants. Okay, and it says a y to the power of a third, and b, what's that, half. That one looks interesting, to the minus 2. Okay, so those are the two questions from exercise 1D. Okay, and they've both got an E next to them, so it's telling you that they've been on past papers. You know, really, that would have been on an old C1 paper. I've seen it. Okay, and it's just GCSE, isn't it? It's like question 1A, literally, on the exam for 1 mark. Okay, so let's just do those then very quickly. That's just the 4th root, and the 4th root of 81 is just 3. 3 to the power of 4 is 81. Simplify this one, so you've got x times 2x to the minus a third, all to the power of 4. Okay, so it's all of this to the power of 4. We'll hold the x over to one side for the moment. All of this to the power of 4, I could, like I did before, write that out 4 times. So it's 2 to the power of 4, which is 16. 2 times 2 times 2 times 2, that's it. And minus a third to the power of 4, well, it's just timesing those two together. So it's x to the minus 4 thirds. Okay. And what are we doing with that? We're timesing that by x. Okay. So let's times it by x. Let's simplify this. Okay. So you've got 16x to the minus 4 thirds times another x, which of course is x to the power of 1. Okay. And when we times two things that are the same here, the x's, okay, then what do we do with the powers? We add them, don't we? So we've got minus 4 thirds plus 1. Well, minus 4 thirds is minus 1 and a third, plus the 1, okay, is minus a third. So this becomes 16x to the minus a third. Okay, the numbers in front here, you can just times, if there's any numbers, you can just times those out. You know, it's just like saying 2x times 3x. You know, again, you just go 6x squared, don't you? What you've really done is you've gone 2 times 3 is 6, but the x times the x is x to the power of 1 times x to the power of 1, and the rule is you add the indices, don't you? You don't think of it like that, but that's that index rule. And we've just done exactly the same here, except instead of being 1 and 1, they're 1 and minus 4/3, so it just looks more complicated. This is A level. Welcome to A level. Okay. This one, question 5, looks a little bit harder. It's saying y is equal to all of this, find y to a third, so it's 1/8 x cubed all to the power of a third. Okay, so that is all of that is your y, so it's all of that to the power of a third. Okay, well, the 1/8 to the power of a third, okay, well, that is the cubed root. The cubed root of 8 is the cubed root of 1 over the cubed root of 8, which is 2. So it's a half. A half times a half times a half is an eighth. So the cubed root of an eighth is a half. And the cubed root of x cubed is just x. Okay, and again you can times out those indices. 3 times a third is 1, x to the power of 1. Or you can write it, of course, can't you, as mathematicians would prefer, as x over 2. Okay, and this one here, so we're doing a half times y, which is all of that, an eighth x cubed to the minus 2. Okay, alright, so I'm going to hold that half to the side. The first thing I'm going to do is going to ignore this minus, so I'm just going to take it as a 2, which means we're squaring all of this. And if we're squaring all of this, okay, we're doing timesing it all by itself, so we're going an eighth times an eighth. In other words, we're squaring that eighth. 1 times 1 and 8 times 8. So you've got 1 over 64 there, and we're squaring this. X cubed times x cubed is x to the power of 6, okay, because we add the indices, don't we? Okay, or 3 times 2 is 6. And then the minus is 1 over that, okay? So this is, again, we've got 1 over 64 x to the 6. Now I'm going to write this as that, okay? So there's different ways of doing it, but that's how I'm going to do it. So all of this, okay, I can write as x to the 6 over 64, can't I? 1/64 of x to the 6. And the minus now, action in this, because we squared it to get that, the minus means 1 over, so it's that. And this is a fraction, isn't it? So we can flip it upside down. Okay, so in other words, we can change that now to 64 over x to the 6. Can you see? Invert and multiply. Okay, so we're down to that. And of course, the last thing we've got to do is we were holding off with that half, weren't we? We've got to times it by a half. And when we times all of that by a half, well, we could write it as 64 over 2x to the 6. Okay, just stay in lining up your 1 and your 2. The 64 divided by 2 is 32, so 32 x to the 6. Okay, and that's your answer. So a lot to do there, really. Again, can we write it any different? Yes, we can. We can write it as that if we want. We can move that x to the 6 up. I'm just making sure this fits on my screen. I think it does. To be x to the minus 6. Okay, so that one's a little bit harder, that one, so you have to be careful with that one. Okay, and that is the last of the indices, the last of the exercise. Okay. Right. So have a go at those. Get your practice with questions 1 to 1, 2, and 3. There's lots of bits to that. You can sort of do all of those. Okay. Remember, in the exercise, when you're doing that exercise, there are some things like in exercise 1D, I can see one where it says that, and it looks like surds, doesn't it? Okay, well remember that is the square root of x, can be written like that, and the cubed root of x is that, isn't it? Okay, and when you times them together, you add the indices, so it's a third plus a half. Okay, whatever that is, you've got to do a third, so change them both into 6, so that is 2/6 and 3/6, so it's 5/6 if you want. Okay, so have a go at those, and then I've got some more. These are ones that I've written for myself. Thought I've just made them up. We talked about these in lesson. This is an extension for you for indices, and I've got 3 for you to do, and I think they get progressively harder. There's that one. So have a go at these first. I made them up myself, so I'm quite proud of them. Okay, and then the last one, number 3. And this is a solve. They're all sorry, these are all solve. And it's 2 to the 2x minus 2 to the x minus 12 is equal to 0. Okay, so put it on pause, have a go at those, and you know, see if you can get any marks for any of them, or do something with some of them that would pick something up. Okay, and put it on pause, have a go, and then I'm going to go through them with you. All right. Okay. Right, you're coming back from pause. Now I know what will have happened here. You will have spotted that these are in the power series of 3, so you would have gone 3 squared for your 9 to x plus 1, and 3 to the power of 4 to 2x minus 2. Now there's actually 2 ways you can do this one. The first way, what you'll probably do without thinking, okay, I suppose the most straightforward way would be just to multiply these out using that rule, x to the a to the b is equal to x to the ab, isn't it? Okay, that's the rule that does this one. It's going to be the rule that does that one as well. Okay, and if we apply that rule, we can say 3 times 2x plus 2, multiplying that out, is equal to 3, and we've got to times all of that by 4, because it's 4 lots of all of that, which will be 8x minus 8. Okay, and then of course 3 to the 2x plus 2 equals 3 to the 8x minus 8, so that must be equal to that, so we can then say 2x plus 2 is equal to 8x minus 8, and then take 2x, so we get 6x is equal to 10, and divide by 6, x is equal to 10 over 6, and cancel down, x is equal to 5 over 3. Okay, don't go to decimals because we don't do that in maths. Okay, we always have fractions. So x is 5 over 3. Some of you might have spotted actually that here 3 to the power of 4, okay, is equal to 3 squared, all squared, isn't it? 2 2's 4, yeah? So that can be written like that, and so then it's all of that to the power of 2x minus 2. Okay, so we only need to multiply that bit by 2. So then we can say, we can just leave this as 3 to the power of 2 is equal to 3 to the power of 2, and then times that together to get 4x minus 4. Okay, so we're leaving 3 to the power of 2 in the brackets rather than 3, and that way we've only got x plus 1 is equal to 4x minus 4, and when we solve that, have I done this right here? Yeah, that's right, sorry. So taking x off both sides, just had a senior moment there, is equal to 5, and then divide by 3, so 5/3 is equal to x. You might have thought I put that on pause there, but no, I was just having a senior moment. I'm 53 this next month, so you know, when you watch these lessons, you do have to understand that. Okay, so there's two ways of doing that one. This one here, remember from what we said, our misconceptions, you can't, you know, combine this. Okay, you can't go 4 times 2. So how could we possibly do this one? Okay, this one is a tricky one, and it's whether you spot this. Okay, the 4, of course, is 2 squared. So this is 2 squared times 2 to the power of x. Okay, so I don't know whether you spotted that. That's clever, isn't it? Which is, of course, is 2, and you add the indices, so 2 plus x. Can you see? Isn't that clever? Okay, so that was the spot. And you might go, oh, how would you know to do that? Well, now you've seen it. Okay, so that was clever. And the 8, of course, we can write as 2 cubed to the power of 2x plus 1. So when you times those out, you've now got 2 to the 2 plus x is equal to 2 times out 6x plus 3. Okay, and now we're back to how we were here, so we can go 2 plus x is equal to 6x plus 3, take x off both sides, 5x, and take 3 off both sides, so minus 1, so therefore x is equal to minus 1/5, divided both sides by 5. Okay, so that was clever, wasn't it? And this one, number 3, well, you know, if we were in class, I'd say, what does that look like? And someone will put their hand up and go, looks like a quadratic, sir. And it is a quadratic, okay? Because, of course, this here, okay, remember that x to the a all to the b is x to the ab. So that AB can be split up either way we want. So we can split that as 2 to the x, can't we? All squared. Can you see? Would be 2 to the 2x. Minus 2 to the x minus 12 is equal to 0. Okay, so we can write it out like that. I hope you're all okay with that. I'm just going to rub that out to give myself a little bit more room. I'm worried about running out of space here. Okay, so now, okay, we just need, I'd always do a substitution, okay, so I'll go 2 to the power of x, let's call that y, 2 to the power of x is y, so now I can go y squared minus y minus 12 is equal to 0. This looks much nicer, doesn't it? And that, of course, is that, and it goes, because I've worked it out, and we've got minus 4 plus 3. Okay, so solving that where they're equal to 0, we've got y equals 4 and y equals minus 3. But we know that y is 2 to the power of x, and it was x in the original equation, so it's x that we're trying to find. Okay, so we've got to remember to stick that back in. So y is 2 to the power of x, that's what it really was. So we're getting rid of our substitution. Okay, 2 to the power of what makes 4? Well, x is 2, 2 squared is 4, and 2 to the power of what is equal to minus 3? Actually nothing. There's no power you can raise a positive number to that will give you a negative solution. So there is no solution to that one. Okay, there's no real solution to this. So the solution is only the x equals 2. Okay, hope that's okay with you. Before you go, just want to show you something. Just over lockdown, I did all my worksheets for my year 10. I did little video lessons for them. Just want to show you some of the pictures that I put on the worksheets. Look at that. Oh my word. Look at that. That was a kingfisher that I did. But I did reproductions of modern art, famous paintings. girl with a pearl in her ear. That one. Remember that painting? Unbelievable. Okay, got another one for you. That bloke with an apple in his face. Yeah? Oh, my word. Okay, and hang on, there's another one. Is it? Oh yeah, no, I was dead proud of that. The Scream. The Scream, I did that, coloured pencils, in about 2 minutes. And I did Mona Lisa. The Mona Lisa, look at that. Unbelievable. Okay, this one's, I started off, my first attempt was, oh, that's Peppa Pig, hang on. Oh, I did SpongeBob. Starry Night. How about that? Van Gogh, Starry Night. You can see I did that quick, but then I spent a bit more time on the other ones. Anyway, just thought I'd show you them. Right, over and out. Have a go at those questions 1D though, fill in the gaps, okay?